Everybody, it's Tyler here at the Lakeshore Qualifier, checking in with the NAC 9956. This team we've been covering for quite a few years so far here. An incredible team. By the way, to speak more about that, I have Jessica, Ben, and Pack. And the NAC here, they built a fantastic machine. Of course, we'll cover their arm that's able to articulate a little bit, great grabber, linear slides. And we're going to talk a little bit about a fantastic initiative that the NAC is really helping spearhead as well, too. So let's learn more about this team coming in the power play here on Behind the Bot.
This video on First Updates Now is made possible by viewers like you and also the following sponsors.
Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Let's start out talking about some mechanical features on your robot. Your robot overall just so well constructed. Let's start out, talk to me about your arm and your intake, and then we'll move into your slides and more.
Yeah, so this is our main vertical arm. This is a dual linear slide system that's run by these two rev motor connected 90-degree gearboxes to help them run simultaneously. The reason we chose this design is to keep it a lot more sturdy when going up and down, because last season we experienced a lot of wobble with our singular slide. And then up here you'll notice this servo that's attached to this smaller arm that with our claw on the end, and that allows us to have almost 180 degrees of rotation, which makes it great for perpendicularly dropping the cones on the poles. Next we have this, so getting to the claw itself. This was almost completely custom 3D modeled. We got a more basic file online, and then we edited pretty much the entire thing to fit our basic needs. So this the grabber towards the end is fit to perfectly fit the cone, and then we also have these foam and rubber bands to help get a firm grasp on that cone when we grab it. And then we have this sensor to help pick up the cones, but Ben will get into that later when he talks about programming. Next we have the drivetrain. It's run off Mecanum wheels to allow strafing, and then we have each wheel having its own motor. We have 3 dead wheel encoders on the bottom. That helps track our movement to with high precision during autonomous and teleop.
Let me ask you, from your cone scoring mechanism standpoint, you have quite a few different articulating points, right? So you got the claw itself, linear slides, and the motion left and right. When you're looking from a match strategy standpoint, how was this, or why was this the best strategy for the NAC to go with? Why'd you choose this route?
Well, every year, every season, we kind of follow the same pattern of choosing our strategy. We watch the game plan video together and talk about what we think some of the key points of the strategy are. This season, we thought having a small, maneuverable, quick robot to get in between those poles, especially with the cones on them, was really important, as well as having an arm that could quickly reach up and quickly come down while staying stable, so we don't have to waste too much time lining it up. The reason we went with this design for the claw, we had a lot of different ideas for what this claw could be, but we ended up going with this because it made having that claw come from the top was really easy to get in on that stack of cones. One idea we had was something that it was almost like a plug. It went into the cone and then kind of pinched out to pick it up. But we ended up going with this because we just liked it a little better. We thought it had more reliability of not getting caught.
Well, obviously working out very well for the NAC so far. Let's talk more about programming and some of the sensors that have gone into your robot. You mentioned a couple already, but I'd love to hear more about that and what you do for autonomous as well.
Yeah, so one of the cool things we started this year is we started using a motion profiling library called Roadrunner, and it's very well known in the FTC community. We use 3 dead wheels, 2 parallel to each other and one perpendicular to the robot. The 2 parallel wheels will track our back and forth movement, and it can also track rotation. So after a lot of tuning and a lot of testing with Roadrunner, we're able to find distances between wheels, counts per inch, and the encoders we have on those dead wheels are very accurate. They can count 8,192 encoder ticks per revolution. And then that middle encoder is used to find movement left to right. Because obviously we have Mecanum wheels this year, and that allows you to strafe left and right. So we need to be able to track that movement. And now we implement that in autonomous by moving back and forth between that cone stack and that pole. We can go on the same exact trajectory, and it's been working very consistently for us, scoring 3 cones every time today. So one of the cool sensors we have is this distance sensor. We have a distance sensor on our claw. And one of the cool things it can do is we made it so it can automatically pick up the cone. What it'll do is it'll look for a short distance over the lip of this cone, and then once it sees a long distance, it knows it's in the center of that cone, so it'll automatically clasp down on that cone and we can go up and down with it.
I love hearing about the automated processes. Looking in the future, what are maybe a couple things you'd like to accomplish looking at a future event for your team?
So we have considered making our robot a little more efficient with an arm that goes out so we have less movement. And one of the cool things we could do with that is we can get a sensor down in our robot here. It'll tell us when a cone's in here, and we don't have to rely on the distance sensor over the cone. And yeah, that's pretty much it. I think we're in a good spot, and I like what we're doing with our sensors this year.
Yeah, I agree. Your robots look fantastic so far, and of course, wish you best of luck for that. One of the things that the NAC has been super proud of is an initiative called First Ladies and First Ladies Wisconsin. So we're going to pass over to Jessica, talk more about what is First Ladies and First Ladies Wisconsin, and how you might be able to get involved if you're interested.
So First Ladies is an organization that's global, and anyone that's involved in STEM and is a girl can be involved. So how we're involved is we're a Wisconsin First Ladies regional partner, and at our qualifier in January we're going to be having a ladies lunch where we will have a panel of engineers that are females come and talk about their experience as being a lady in STEM and fielding questions about that. Their website is www.ladiesinfirst, and on there you can sign up for their monthly blog where you can hear about fun activities other people did or just fun stories from the FIRST community. It's also an amazing way to meet other girls in FIRST, especially if you're the only girl on your team. And it's worldwide, and you find a ton of resources on there for things like funding, grants, scholarships, all those kind of things.
Well, Jessica, thank you so much for talking to us about First Ladies in the NAC. We wish your entire team good luck this season in Power Play. Thanks for telling us about your robot and First Ladies Wisconsin, and wish you the best. Take care.
This video on First Updates Now is made possible by viewers like you and also the following sponsors.
At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity.
Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.